Okay, so we're going to finish up the homogeneous set. And then we'll go from there. So the homogeneous set means that, or homogeneous system, every constant term is 0. And we also know that it's always consistent. And it's always consistent because it will always at least have the solution 0 for a XYZ, for a three-dimensional. It'll always have the solution 0, 0, 0. Now, it may have other solutions as well, but it will always have the trivial solution. And so we're going to solve this one out in just a second and talk about that one. So one of the questions on your homework was, give me a characteristic of the a homogeneous system. And one of the characteristics is that the constant terms are always 0. And another characteristic is that it is consistent. Now, when you solve a system of equations, one of three things can happen. You can get one unique solution. In this case, in the case of a three-dimensional, it would be one unique ordered triple. You can have no solution, or you can have infinitely many solutions. Now, the reason I wanted to talk about this one more time is that you can have one that has 6 solutions. It's either all, nothing, or 1. That's it. So you can have one that has 4 solutions. That doesn't work either. So these are your only possibilities. Either there's one single unique solution, no solution at all, or infinitely many. In the case of a homogeneous system, no solution is not an option because it might be the trivial solution. It always has a trivial solution. So if it has the one unique solution, that would be the trivial one. So it's either going to have trivial or it's going to have a parameterization that it's going to have infinitely many. Those are going to be your only options. And down the road, this fact of whether it has one solution or infinitely many is going to tell us things like if it spans or if it's independent or if it's dependent. It'll give us some theory-based items a little bit down the road. Okay. So now then, we're going to take this system that you see, hopefully in your little note packet from, seems like a year ago, but your little note packet, we're going to solve it out. So I've got a 1 and a -1 and a 3 and 0 and 2, 1, 3, 0. Okay, so when we solve this one out, we're going to see if it does have just the trivial solution or if it has infinitely many. All right, the first thing I'm going to do is get rid of this 2. So I'm going to say -2 row 1 plus row 2 is going to give me a new row 2. And that's going to be my new row 2. Now, I'm also much better at this. I hope we all are much better than this, but I'm also much better at this now than I was a week ago, right? And so I know, hey, that's going to be a 3 there. What am I eventually going to want there in that 3 position? A 1. So I'm going to go right here and do 2 birds with 1 stone. So after I get this new row 2 right here, I'm going to say 1/3 row 2 gives me a new row 2. And so then I'm going to have it as 0, 1, -1, 0. Just to save us some time, save us some space, save us a little hassle. Okay, so I just did two different little steps there because I know I've got to get a 1 in that position. Now you're welcome to write it out every time, that's fine, but that'll save you a little time. Do you have any questions with that part? All right, so this is technically in row echelon form, so we can stop there and work it, or we can get it in reduced row echelon form, which means we get rid of the -1. Either way works. You can make it work either way. But the easier way to write it as a parameter is to put it in row echelon form, which means I want to get rid of this guy right here. So I'm going to say row 2 plus row 1. And remember, this is what I'm trying to change, so I'm going to make this a new row 1. So I'm going to say 0, 1, negative 1, 0, 1, negative 1, 3, 0. And that's what I'm going to get. Excuse me. All right, now at this point, I can write it easily, hopefully, with a parameter. Right, so if I write it out with a parameter, I know the top line is going to be x plus 2z equals 0. Okay, so x is going to equal negative 2z. My second line is y minus z equals 0. So writing that one out, moving the z over, y would equal z. Okay, so I'm going to let z be my free variable. So z is going to equal t. That means y is going to equal t. And that means x is going to equal negative 2t. So the answer to this particular one here would be, and we'll move out of your way in just a second, infinitely many solutions of the form negative 2t, t, t. And that's how it would look. And that's how you would solve it out as a parameter.
Is it infinitely because y equals z? Is that what makes it infinitely? Because I know we talked about when you get 0 equals 0, that's when it's infinite.
Yes. There's one little thing I'm looking for in my textbook. That's a very good question. And just in case you couldn't hear it, he said, is it infinitely many because y equals t? Is that what you said? Z. That is not why it's infinitely many, but I'm looking for the little clause. I just have to find it here. There it is. Okay, so in your textbook, and I don't know that I put it in your document that I printed for you or not, but it says, is this theorem 1.1? In my book, it's on page 21, but I'm the lucky one that gets this beautiful book with pages that you can look through, right? So that's not an e-book because I like paper. But it says on that theorem 1.1 on page 21 of my text, it says, every homogeneous system of linear equations is consistent. Okay, so we talked about that. And it says, moreover, if the system has fewer equations than variables, then it must have infinitely many solutions.
There's 3 variables and 2 equations, so that would be.
Okay, perfect. So just like Jenna just said, I'll make sure we get it on the video. Since this particular example on the previous slide, which I'll refer to in a second, has 3 variables, but only 2 equations, Okay, for a homogeneous, then it must be infinitely many. Okay, so that is how we know. So going back to this one again, we had x and y and z. So you would think a traditional example of x and y and z should have an equation to represent x's, an equation for y, an equation for z, right? Because when we solve something out in reduced row echelon form, we would get an x and a y and a z. But since this one only had 2 equations but 3 variables, we knew it was going to be infinitely many from the start. Okay, now, finally, I finished up the homework, the section 1.2. We finally finished it. We are ready to review for your test. Okay, so what you have to review for your test is, to review, you have a definition short answer sheet. Okay, so on your test, you're going to have some definition and short answer. Okay, the only ones that are definitions or short answers that I'll give you are on this. Now, I didn't write your whole definition list out, right? Like I didn't say inconsistent means this, consistent means this, right? I didn't ask you that. I'm also not going to ever ask you to give me the definition. So it's not going to say, what is the definition of a consistent system? Okay, but I might ask you, a system that has a solution is called blank. A homogeneous system has this characteristic, that type of thing. So those are the types of things that I'll ask you. Give me an example of an augmented matrix. What's the difference between Gauss-Jordan and Gaussian elimination? Solve a system there, write using a parameter. So these will be, that just gives you a guideline. I'm not going to ask you any definition that's not on that sheet. Okay, so that's first. You also have homework 1. You have homework 2, which isn't due today, so you can ask questions, but you can turn it in today if you'd like. And then you have worksheet 1. Okay, and your test is Monday. Okay, so those are the items that I would study. Now, what I'd like for you to do is get out those items and ask me questions. I'm going to get out those items and look as well. Okay, letting you know how your test is broken up. You have a page of short answer. So just fill in the blank. What's the size of this matrix? This matrix has size 4 by 9. How many rows does it have? That type of thing. I'm going to ask you a group of problems for reduced row echelon form, row echelon form, and neither. So if you look at that weekly assignment there, that's where those are going to be, just like those. That's your test. test 2. There's the worksheet. I don't think I have your test 2. Okay. One of the questions on your weekly assignment 2 gave you a problem that says, write the system has been reduced down by elementary row operations to this certain matrix. Write the correct system. Okay, and so that was number 13 on your homework. And I didn't go over one quite like that, but I will be glad I guess I kind of went over it like this one. It's infinitely many, yes. So you write it with a parameter. So with number 13, it's going to look kind of like this one, except it's not quite as bad as this one, I guess, because you didn't have to, it was already simplified down, but you're going to write it as a parameter. So you would have like x plus 2z equals 0, and then work it down that way. So if you need help with number 13, I'll be glad to do that for you. That's the only one that I think that was just a little bit different.
Could you go over number 7?
Yes, but I'm going to borrow your number 7 because I can't find my sheet, and I'll give it right back.
I think I got
Okay, you missed one. So let me show you the one you missed. And we'll use you as my guinea pig. Okay, so where I am, this is on weekly assignment 2. This is number 7C, and this is number 7D. Okay, both A and B, just for the record, A and B are both neither, as you said. And they're both neither because A is neither because it has a 3 in the top left position. And in the top left position, it would have to have a 1. B is neither because, remember, any 1 has to be to the left of the row in the row in front of it. So you could put B in row echelon form by switching rows 2 and 3. And so then that brings us to these two. Okay, so row echelon form means that the first entry has to be a 1. Okay, it is. Great. And any 1 that it does have in the upper row has to be to the left. Okay, so this one right here is to the left of this one. That's true. And so that one would be in row echelon form. Now, you'll say, well, it needed a 1 right here. It didn't have to have a 1 right there. The solid row of zeros is at the bottom, so that's okay. Now, the characteristic of reduced row echelon form is that any 1 in the problem has to have zeros above and below it. Okay, so this one has zeros below, and this one has zeros above and below. So since the 1s have only zeros above and below in those columns, this one is actually called reduced row echelon form. Okay, so now let's look at 7D. When you look at 7D, it has 1s on the main diagonal, which is always an easy thing to notice. Every 1 that it has is to the left in the row, the preceding row. It's to the left, so that looks good as well. If I look at this column right here, it has the 1 and the zeros, great. And this one has the 1 and the zeros, great. So those look good. But this one doesn't have the zeros. Okay, but it's still in row echelon form, but it's not in reduced row echelon form because of the 3 and the 6. So this one is just called row echelon form. And that's how those would go. Do you have any other questions with reduced row or neither?
So when it's reduced, you only look at the 1s, and if they have zeros above and below?
Well, for both, to determine, you're going to look at the 1s in both cases. If it only has zeros in that column, zeros and ones, it's reduced. If it has anything other than zeros and ones, it's not reduced. It's still row echelon, but not reduced. Okay? Do you have any other questions on, let's stay on that sheet for just a second, that worksheet 2, homework 2 sheet, weekly assignment 2. Do you have any other questions on that one? Any questions on anything else that you think you would need before the test?
For number 2, I didn't say like each of the constant terms in it. I said the constant matrix of the homogeneous augmented matrix is a null matrix. Those are supposed to mean the same thing, but you'll be able to know what I mean by that.
I do. Yes, I sure will. You're so formal. I love it.
Yeah, I
Yeah.
love being formal whenever it comes to the subject I'm very familiar.
Okay, awesome. Huh.
I have a question on the first one.
Okay, and we'll see. Get your paper, and I'll ask it, and I'll give your paper back where you can see it. Which one was it? The last one. Okay. So her question was from the Gaussian elimination. Back from the first one. All right, do you have the original paper? Yes. Oh, it came from the book. Okay, there you go. It's no problem. The reason that I asked you for that, you're going to think it's funny. Well, you may not think it's funny, but I think it's funny. All right, guys, I'm going to need some help with it. So, more than likely, I can't speak for Natalie, but she didn't get it right, but I don't necessarily know that she made a mathematic error. When I work one of these, and I miss it, it's usually because I didn't copy it initially from the book properly. And since I gave you that as an ebook and you had to find it in the ebook, all that stuff, it's very easy to miscopy it. So, if somebody has that week 1 homework pulled up, double check this for me.
Is this number 4
Yeah, that's the last one. It should be.
Here, I'll take the flip-flop.
Okay.
Yeah, because I wrote down and completely wrote the wrong one when Joseph was doing it on the board.
Okay.
I was like, I wrote the
Is this-
wrong problem.
Does it look right?
That's what I wrote down.
Okay, great. All right, then we do have an error in there somewhere, but more than likely, always double check it. So let's say you get on your test and you're like, this is not working. I'm getting a repeating decimal, which I will never give you. It could be that sometimes I just tell people, just scrap it all the way, get you a new piece of paper, and start from scratch. Because a lot of times that's what happened. We made a careless copying error, and then once we do that, we make the same error over and over. All right, so we've got 1, 1, 1, 2, negative 1, 3, 2, 8, 4, 1, 0. Make sure we have that part right, and a 4. All right, so that's how it's going to start. Now I'm going to go a little quickly through it. I'm going to get rid of the negative 1 and the 4. So to get rid of the negative 1, I'll say row 1 plus row 2 gives me a new row 2. And to get rid of the 4, I'm going to say negative 4 row 1 plus row 3 gives me a new row 3. All right, so other than being messy, I think I like it so far. Unfortunately, I brought my test 2 folder instead of my test 1 folder, and so I don't have the answers, so definitely double check for me. All right, so unfortunately, we need to get a 1 where that 4 is, or the -3 is, one of the two, and either way I go, I'm going to get fractions. So I'm going to say 1/4 row 2 gives me a new row 2. So let me double check that one. So I have 4/4, 3/4, and 10/4, which is 5/2. There we go. All right, so now then, my number one's going to stay, my row 1 rather, is going to stay the same. There we go. And then I have to get rid of that -3. So to get rid of that -3, I'm going to say, using this blue one, 3 row 2 plus row 3 would give me a new row 3. 0, 3, 9/4, and 3 would be 15/2. 3, 9/4, 15/2. Okay, so I'm going to get, oh, I can actually move this one. Here we go. 0, 0. 9/4 minus 4. Okay, so 4 is actually 16/4. So 9/4 minus 16/4 would be a -7/4. And 15/2 minus 4, in 4s and halves, this would be 8/2. So 15/2 minus 8/2 would be a -7/2. Double check it. Yes. Yay. Good job. They're both, now let's see, this one's negative for sure because the 16 was, but this one you're right because that's the larger one. Perfect. Now, as I look at this, because remember I didn't bring my notes with me today, so I'm winging it. I missed a sign. That sign messes the whole thing up. So do as I say and not as I do, right? If I was working it, I probably still would have worked it this way because that's the way that Gauss-Jordan says to work it, or Gauss says to work it. But another thing that you could have done, if you didn't like all these fractions, you could have right here at this point said row 2 plus row 3 gives me a new row 2, because you can add 2 rows, right? And that would have given you a 1, and you're not in 7/4 land, so that also would have worked if you had chosen to work it that way. Yeah, you don't have to work it. There's so many. Yes. Mm-hmm.
Oh, I never worked with fractions.
Okay. Well, no, I don't need. I can't start it over at this point. But
This is what I did.
3 row 3 plus 4 row 3. So you got the answer. Yes, but so that's this. Oh, I don't know what happened to it. That's what we want to do with it, right? There it comes. Now then, so there's, like I said, multiple ways to work it. But you could, if you're trying to get a 1 there, there's multiple ways to do it. But the easiest way, not the easiest way, the way that Gauss said to do it is to get a 1 in that position, and that's how we would work it. But you could have said that way. There were, like I said, other ways to do it as well. Now, when I look at this bottom one here, I need to turn this -7/4 into a 1. So the way that I can turn a -7/4 into a 1 is to divide it by -7/4. Okay, and dividing by -7/4 is the same thing as multiplying by -4/7. So if I said -4/7 row 3 gives me a new row 3, I would say -4/7 times 7/4 times -7/4. There we go. So that would give me a 1. And -4/7 times 7/2 would give me a -2. Now, if you didn't want to do it all at once, you didn't have to. You can multiply everything through by 4. And if you multiply that bottom row by 4, you get 0, 0, negative 7, 14. And then you could divide everything through by negative 7, and that's how that part would look. Now, there we go. There we go. Okay. So we got that z is negative 2. Great. So let's backtrack. So I'm going to get y plus 3/4 times z equals 5/2. So this is y minus 6/4 equals 5/2. Okay, so remember we'll get a common denominator here, which is going to be 4. So this is going to be 10 plus 6, which is going to be 16/4. So I'm going to get y is 4. There's my second one. And then for the last one, I'm going to get x plus y, which is 4, plus z, which is negative 2, equals 2. So x plus 2 equals 2. Subtract 2 from both sides, and x would equal 0. So my answer would be 0, 4, negative 2. Now, here's what we've learned from that crazy example. I am positive that I did not work it that way when I worked it, when I initially assigned it. I just didn't have my notes with me today, right, from the quiz. But I'm positive I didn't work it that way because I avoid fractions at all costs, and these fractions were terrible. Okay, I know Joseph didn't because I saw his work. But a lot of times people say, are you going to give us one like that on the test? And my answer is maybe, which is a terrible answer, but here's why. When I assign one on a test, I think of it, get the 1, get the zeros. Get the 1, get the zeros. Get the 1. And so I work it a certain way, and when I work it, I make sure the way I work it, I don't have fractions. But that doesn't mean that you don't work it a different way than me, and it doesn't mean that you won't get fractions in the middle because you chose to do it a different way. But I try really hard not to make you have these fractions like this, but sometimes they just turn up just based on the way that you worked it. Okay, that is what you got, the right answer. Okay, perfect. We just went terrible. We hit the bumpy road. We went down the bumpy road. Okay, are there any other questions with any of the material?
So you said we had the option of doing the Gauss-Jordan or the Gaussian integration?
I'm not going to make you do Gauss-Jordan.
On the practice test,
I think I probably told you to do one on the practice
it
test.
says use Gauss-Jordan on at least one.
Yes. And I'm not, you guys are a small little class, so I don't really press you like I do the others or have in the past. But I'm not, if you want to practice using Gauss-Jordan, that's great. But you can use back substitution. That'll be fine.
I have one more question.
Okay.
Just a general question about credit. So say I'm going through the system and I notice that it's going to be something doesn't equal something else. Can I stop there and say no solution?
Yes, you
Okay.
can. You can. Because sometimes it's one of those things where you multiply a row by 2 and then you realize, oh, that's the same row as I see there. As soon as you realize that red flag, you can stop and then finish from there. Any other questions?